For more videos like this for Discrete 1, you can take a look at Sarai Studies, link is in the description box below.
In part 1 of this video, we talked all about satisfiability. In this part, we talk about consistency. The definition is a set of compound propositions. Remember that we label or symbolize compound propositions with this symbol. We pronounce it phi. So here we have compound proposition 1, compound proposition 2, all the way until m number of compound propositions, however many we have, that are made up of one variable up until n variables, is consistent if and only if. Remember, when we do definitions in this class, we have to use if and only if. That's how we write definitions formally. If there is at least one truth assignment of the propositional variables p1 to pn that make all of the compound propositions true. First question, is this set of compound propositions consistent? So we have one compound proposition, we have another compound proposition. This one is made up of two variables, two propositions p and q, and it's p or q. Here we have compound proposition 2 that's made up of p and q, and the compound proposition itself is p or not q. Is it consistent? That's just a fancy way of asking, is there at least one truth assignment, in this case of p and q, that can make both of these true at the same time? We're just looking for one row where both of these are true at the same time, where they're both consistent. So let's do a truth table. The first question is, how many columns do we need? In each of these cases, we have two propositions, so we're going to have one column for each of these propositions. Also notice we have not q, so we might want one for not q. And then, of course, we need columns for the actual things we want to find the truth values of, and that's these two compound propositions. So one for this one and another for this one. And just to be fancy, we can replace this with compound proposition 1 and this one with compound proposition 2. Second question is, how many rows do we need? Remember that number of rows is equal to 2 to the n, where n is the number of propositions that you have. We have two propositions, p and q. So that's 2 to the second power, which is 4, so that's 4 rows. Now the question is, how do we fill out the truth table? We take the number of rows, which is 4, divided by 2, write it below the first column. Let me move this down right here, and then keep dividing by 2 until you get to 1. We got to 1, so we're done. This tells you how many trues and falses you want to have to start off with, and you want to start with trues. So 1 true, 2 trues, I used up all my trues, I move on to my falses. 1 false, 2 false, I used up all my falses, and I'm also done with the column, so I move on to the next. This tells me I'm going to start off with 1 true and 1 false, so 1 true, 1 false, I used up my trues, I used up my falses, I still have space left. What am I going to do? I'm going to copy and paste the pattern that I just wrote right over here until I run out of space. So that's true and false. I ran out of space, I'm done. Now q is just a fancy way of saying the opposite of q. So if q is true here, it's going to be false here. If it's false here, it's going to be true here. If it's true here, it's going to be false here. If it's false here, it's going to be true here. Then the compound proposition 1 is p or q. Remember that in order for an or to ever output true, at least one or the other has to be true. In other words, we're only looking to see if there's at least one true. So we're looking p and q, these two columns, and we're just looking for one true. Here we see one true, so it's going to be true. Here we see one true, so it's going to be true. Here we see one true, so it's going to be true. Here we don't see a true, so it's going to be false. Then for compound proposition 2, we're looking for p or not q. Again, it's an or. In order for an or to give you true, at least one or the other has to be true. So again, we're looking for at least one of these, either p or not q, to be true. So we're looking this one and this one. Here I see a true, so it's going to be true. Here I see at least one true, so it's going to be true. Here I don't see at least one true. They're both false, so it's false. Here I see at least one true, so it's true. Now we're done with the truth table. Can we tell if these two compound propositions are consistent or not? Remember that compound propositions are consistent if they're all true at the same time, and here they are both true at the same time, or at least one truth assignment of p and q, because the variables here are p and q, and those truth assignments are where p is true, q is true, or these compound propositions are consistent when p is true and q is false. So we could say yes, these set of compound propositions are consistent, and one assignment that makes them consistent is where p and q are both assigned true. Let's try another one. Here we're asking, is this set of compound propositions consistent? In other words, we're looking for at least one row where all of these compound propositions are true. So for the truth table, how many columns do we need? Well, to start off, it just depends on how many propositions you have. You have two propositions, and actually it's the same number of propositions here, so it's going to be the exact same way we started off here with just p and q. And then I noticed we need the opposite of both p and q, so I'll add columns for those. We already know what not q is. We did it over here. It's just the opposite of q. Not p is the opposite of p, so true, false, opposite of true, false, opposite of false, true, opposite of false, true. And then we will need a column for the compound propositions themselves. We already have this one as a column, so that's fine. So let's do one for p or q, which we can just replace with compound proposition 1, because that's what it is. And then one for this one, p or not q. And then this one we can replace with compound proposition 2, because that's what it is. And not p can be replaced with compound proposition 3. Now let's zoom in here. Compound proposition 1 is just p or q. Remember, or only outputs true if one or the other is true. So you're literally only looking for at least one of them to be true. In other words, you're looking at P and Q, these two columns, and you're just looking for at least one true. Here I see at least one true, it's going to be true. Here I see at least one true, it's going to be true. Here I see at least one true, it's going to be true. Here I see no trues, so otherwise it's false. Compound proposition 2 is P or not Q. Again, you're just looking for one or the other to be true. So you're looking at this column P and not Q over here. Here I see at least one true, so it's going to be true. Here I see at least one true, so it's going to be true. Here it's going to be false, I see no trues. And here I see at least one true, so it's going to be true. So ignoring everything else, we're just looking for at least one row where they're all true. Let's look at this first row. Are they all true? No. Here I see a false. Second row, are they all true? No. Here I see a false. Third row, are they all true? No. Here I see a false. Fourth row, are they all true? No. Here I see a false. So because there isn't at least one row where these compound propositions 1, 2, and 3 are all true, then no, this set of compound propositions are not consistent. Because there are no truth assignments of P and Q, no truth assignments of P and Q, where all of these compound propositions are true. If this was a true, then yes, we could say that compound proposition 3, 1, and 2 are all true. I found at least one row. So the truth assignment of P and Q that's going to give me all true for all of these compound propositions is P being true and Q being true. But that's not the case. There is no row where all of them are true. So it's not consistent. If you're asked to find if a set of propositions are consistent, you're just looking for at least one row where all compound propositions, so S for plural, are equal to true. And that's it for this video. I'll see you in the next.